Hello everyone and welcome to another video here of the Hidden Quantum Champions. In today's video we are going to check out a company called Algorithmiq with Q at the end. And with that, let's hop right into the website. So here we are on the website of Algorithmiq. It says bringing quantum to life. We are reshaping the future of healthcare and life sciences by developing quantum algorithms that unlock the power of quantum computing. So again, we have a focus on the quantum algorithm side here, and even more, this company is focused on the healthcare and life sciences part of quantum algorithms. So let's scroll down a little bit further. It says from quantum science to life sciences. We developed quantum algorithms that seamlessly integrate the best classical computers with the most advanced quantum computers. Our cutting-edge quantum solutions are designed to push the boundaries of scientific discovery at an atomistic scale resolution. With these innovations, we aim to resolve life science problems that are currently deemed impossible. So then we have these 3 points here: quantum computer interface, quantum algorithms for chemistry, and then quantum algorithms for life sciences. It says our digital quantum interface seamlessly integrates the best classical computers with the most advanced quantum computers, unlocking new possibilities in computational power. Applications range across all industries, from new materials and drugs to green energy, new generations of batteries, and more. So here we see a broadening up of the applications, not only in life sciences and biological topics, but also green energy, new generations of batteries, and more. Then it says quantum algorithms for chemistry. Our proprietary quantum algorithms for chemistry are unlocking unprecedented ways to solve complex many-body problems in quantum chemistry. And then finally, in the quantum algorithms for life sciences, it says we are revolutionizing drug discovery and development with our novel multi-scale approach that leverages both quantum computers and artificial intelligence to open exciting new pathways for targeting rare diseases. So, as we see, the target is very much on the chemical and drug development side of things. And I mean, there are different religions on where quantum computers will first bring a really big advantage. There are different opinions on that, and I'm not fixated on one, but I think there's a very logical chain of argument saying that, okay, a quantum computer works using or making use of the laws of quantum physics, so it kind of naturally makes sense to use it to simulate quantum systems or actually emulate those, because it is a quantum system itself. So if you are looking into chemistry problems, for example, chemistry at the very ground of it, at the very basis, is a quantum physics problem, because you have interaction of electrons of different atoms and molecules. So at the end, this is a quantum physics problem. And therefore, the argument goes, it kind of makes sense to target those with quantum computers, and it feels natural that a quantum computer should perform better on these tasks than a classical computer. But additionally, we see here also it says they also use artificial intelligence to open exciting new pathways. So there's also a combination of quantum computing and artificial intelligence. So this idea of using quantum computers to encode neural networks, for example. Now here it says trusted by, you see Harvard University, University of Oxford, Imperial College, and there's also other universities that are using this apparently. Then it says at the forefront of quantum computing and chemistry, led by expert scientists in the field of physics, quantum information, and quantum computing, we take pride in publishing our findings in top-tier peer-reviewed journals like Nature, Science, Physical Review Letters, and sharing our knowledge at the world's top quantum conferences. And then there's this research button here, which you can click to move on to their research publications. On top of that, what we see down here is they are based in Helsinki, Finland. Okay, with that, let's take a look at what else we can find here on their website. So there is something on the products, something on the solutions. Then, of course, there's the research tab that we just saw and some information on the team. Let's start with the products. It says quantum computers without good quantum algorithms are dumb machines. As part of our mission to revolutionize life sciences, we recognize that quantum computing requires breakthroughs for efficient use of the hardware. To achieve this, we have developed the necessary innovations to drive this transformation forward. Tools such as our proprietary quantum algorithms, tensor network error mitigation, are now available to a wide range of industries, including material science, optimization, quantum software, and machine learning. Then it says digital quantum interface, introducing DQI, our groundbreaking digital quantum interface, a platform designed to seamlessly connect quantum computers with classical systems. This integration enables us to harness the full potential of both technologies in the most optimal way. Our unique approach utilizes informationally complete measurements, a patented method allowing us to post-process quantum computation results with cutting-edge classical algorithms like tensor networks on the most advanced HPCs or high-performance compute platforms. Experience the future of computing with DQI, where quantum and classical innovations meet. And then it says available at IBM Qiskit as IBM Qiskit function. So IBM Qiskit, IBM is this big technology company. Qiskit is a quantum computing programming language that is developed by IBM and is an open source platform for everyone to use. And that can be used in order to program quantum computers, either on, let's say, a very bottom level, as in really operating on gate operations, as like, perform a Hadamard gate. But you can, of course, also go up in the way that it's being used in the API interface, as in like using top level functions that are built out of multiple of these operations. Now, moving on, it says a measurement toolbox. Achieving the levels of precision required for certain applications can be challenging for quantum computing. At Algorithmiq, we make the most of informationally complete measurements to reduce errors, save computational resources, and ensure we deliver quality and precision. Then error mitigation toolbox. Error mitigation is crucial in quantum computation to ensure accurate and reliable results, as quantum systems are highly susceptible to errors. At Algorithmiq, we develop optional error mitigation methods that are scalable and efficient across various applications, enhancing the performance and dependability of quantum computations. And then finally, we have the circuit optimization toolbox. Efficient quantum circuits speed up algorithms that reduce errors by minimizing the number of quantum gates and operations. This optimization is crucial for maximizing quantum computers' potential. At Algorithmiq, circuit optimization is a core focus, ensuring our solutions are powerful and precise. Quick point on these different topics here. Error mitigation. So I think I mentioned that already in previous videos, but I just want to quickly point out on that one again. So there is error mitigation and error correction. Error correction is where you really use physical qubits and apply a active correction algorithm on top of that. So you're basically using a lot of physical qubits to then create one digital qubit. And this digital qubit is basically a system out of these multiple physical qubits, and it's being operated as an algorithm. So let's say you, for example, have one qubit that is flipping for some reason, then this is actively being corrected by this running error correction algorithm. This becomes important as you scale the systems, because let's say the bigger your operations are, or the more operations you want to do, the more important it is that you actively correct for those errors. Now, on the other side is the error mitigation. Error mitigation is, let's say, an algorithmic technique that is acting on the physical qubits, so on the on the qubit in your system, and is correcting for errors that might, for example, happen because a gate is not applied accurately. So this is making use of, for example, statistics and understanding of how the quantum system is being set up in order to mitigate for those errors which are happening. And this kind of a bridge solution between, let's say, physically not perfectly functioning qubits and fully error-corrected qubits. So it's like in the transition between those. Then we also have the circuit optimization toolbox here. That was also mentioned before. It is used to kind of minimize the number of quantum gates. So what does that mean? Basically, with every gate that you're performing, there's a chance that you're introducing an error. So you cannot perform an infinite number of gates on existing quantum machines as of today. So in order to compute, to create, let's say, some meaningful result, you want to make sure that the information processing is happening as dense as possible. So instead of, let's say, performing one gate and the next gate and the next gate, you might be able to fuse those three gates into one and then just perform one gate that acts similar to these three gates done one after the other. And that way you only have one operation instead of three. And that way you can, let's say, optimize the runtime on your system, and therefore you can run more, or let's say, you can run longer algorithms in shorter time, and that enables you to actually create something before you run into decoherence, before your system is collecting too many errors. So it's kind of a intelligent way of compiling an algorithm into something that can be executed on the machine very efficiently. And that is also very important for today's machines. Then we see Aurora here. Aurora is our state-of-the-art quantum chemistry platform based on breakthrough quantum software for molecular simulations in chemistry, material sciences, and life sciences. Integrated with our digital quantum interface, it seamlessly combines them with industry-leading chemistry software packages. Aurora enables ab initio simulations based on quantum mechanics and applied quantum-inspired methods to optimize data-driven solutions in bioinformatics and network biology, pioneering a new framework called quantum network medicine. So that's a lot of information. We see that, so on the one hand it says it is a quantum software, so it's a whole software package, I assume, that is optimized for molecular simulation, chemistry, material science, and life science. So it is a software package that is optimized for these fields. So I guess it's optimized for pharma companies that want to start developing something with quantum computers, with quantum algorithms. It says it seamlessly combines them with industry-leading chemistry software packages. So it's meant to be an add-on for already existing simulation frameworks, for already existing techniques that are being used today already in, for example, pharma, to create new or to do simulations of new type of materials. Then it says ab initio based simulations on quantum mechanics. So it basically works as it works on the base principle, and then it works. Let's say it works from the fundamental principles. It works its way up to let's say the full material simulation, to put it short, and then it's meant to be used for bioinformatics and network biology. And the framework is called quantum network medicine, which is a wording that I've also not heard before. Now, quickly on the solutions that they have. So now I guess we go to the algorithm side, as in what can the algorithms actually do? How does Algorithmiq support life science companies? So it says quantum algorithms for chemistry and life sciences. We offer customized solutions through partnerships and client-focused collaborations, ensuring that quantum computing tools meet specific industry needs. And now we see different use cases here. Use case number 1, quantum simulations for the optimization of photodynamic cancer therapy drugs with IBM and Cleveland Clinic. Algorithmiq, IBM, and Cleveland Clinic are pioneering the development of breakthrough quantum chemistry approaches to rationalize and optimize photosensitizer drugs for clinical use in photodynamic cancer therapy. With Algorithmic's state-of-the-art drug discovery platform Aurora, IBM's world-class quantum hardware, and Cleveland Clinic's extensive experience in the relevant pharma applications, the partnership aims to demonstrate quantum advantage for photochemistry-driven quantum application in drug discovery and development. So here we see a consortium of basically the algorithm provider, which is Algorithmiq, the hardware provider, which is IBM, and the clinical provider or the clinical expertise coming from Cleveland Clinic, and then basically them working together on this specific use case. There are another 2 use cases. The second one is about paving the way towards fault-tolerance quantum computing for drug metabolism with QCI. And the third one is quantum network medicine and epilepsy with Cleveland Clinic. Let's only check out the second one and then move on in this analysis of the company. So Algorithmiq has entered into a partnership with Quantum Circuits Inc., QCI, to investigate the reaction rate of the enzyme aldehyde oxidase, AO, in order to accurately predict AO-mediated drug metabolism. QCI's hardware possesses a unique qubit architecture which incorporates error detection, a key ingredient for error correction, and together with our proprietary error mitigation technique, we aim to set the foundations for the transition towards early fault tolerance era. So here again we see a partnership between a hardware provider, in this case Quantum Circuits Inc., and then of course Algorithmiq as the algorithm provider, not only working on, let's say, the solution layer as in this enzyme aldehyde oxidase process, but also in this error mitigation and error correction side of things. Okay, with that, let's quickly move on to the team. So it says we use quantum computers to create a healthier future. Our cross-functional team combines world-class experts in physics, chemistry, life sciences, computer science, and engineering. Backed by experienced leadership and high-caliber investors, we are committed to transforming theoretical breakthroughs into practical quantum solutions for real-world applications today. Then we see here the co-founders, which is 4 people over here. We see research and development. There's a couple more people here. Product and technology, business operations. Then there's also investors and board members linked down here. With that, I think we are already at the end of today's video. I hope you liked it. If so, please make sure to give it a thumbs up. And if you don't want to miss out on the next one about the next company from the quantum technology space, then make sure to subscribe to this channel. And with that, I hope I see you in the next video. Bye bye.